Okay. Sodium hydroxide reacts with sulfuric acid in a neutralization reaction shown below. So they've given us our equation. We can understand it a bit further because H2SO4 is actually a diprotic acid. So it's going to give us HSO4. I should write it properly. So let's do it properly here. H2SO4 plus water is going to give us HSO4 minus plus H3O plus, and then HSO4, and I should stop making so many mistakes. So this is actually a strong acid, so it's going to go completely. And then HSO4 minus is going to be a weaker acid, giving us SO4 2 minus plus H3O plus, and sodium hydroxide is a strong base, giving us Na plus OH minus. So if we sum up these reactions here, we would cancel this, and we would need 2 times the OH minus to balance. There are 2 H3O pluses here, and so we would multiply this guy by 2. And so we would have H2SO4 plus 2 NaOH is going to give us SO4 2 minus plus 2 Na plus plus 2 H3O plus 2 OH minus, which these are going to balance into 4 waters. But there was also 2 waters on this side, so net 2 water. So I should add those in just to keep that. And is this not balanced, or was it not balanced in the question? 2, 4. Oh yeah, it's not balanced in the question. Okay, cool. And so these 2 waters, will drop that down to 2, and so it'll be H2SO4 plus 2 NaOH goes to, we can combine our sodium sulfate if it, just to match the question, although in reality it's going to be in solution likely as its ions, and plus 2 water. It should be 2, because if we look, right, there's 4 plus 2 oxygen, so that's 6. So we need 6 oxygens on this side, which is what we have. 2 plus 2 hydrogens is 4, so now we have 4 hydrogens, so that's the only way that this chemical equation will balance. But the number of waters don't really change the question or the solution, so that's the reason why it was left off in the question. Okay. So now to move on with the problem, so I just wanted to write out the equation because it's good for understanding where the 2 sodium hydroxides for sulfuric acid comes from. Okay, so what is the mass in grams of sodium hydroxide to completely react with 100 mils of a 0.5 molar sulfuric acid solution? So if our concentration of H2SO4 is 0.0500 molar, so that's moles per liter, and we have a volume of 100 mils, so now we can get our moles. So N is just our concentration times our volume, which is 0.05 moles per liter, times 100 mils, times 1 liter per 1,000 mils, just to for the unit conversion. So the mils will cancel, the liters will cancel, and we'll be left with moles, and that comes out to be 5.00 times 10 to the minus 3 moles. I'm just keeping significant digits in there. Yeah, because it's 100.0. And so that guy's 3 sigs, and that's 4. Now, it wants the mass in grams of sodium hydroxide, so we can relate our number of moles here from our balanced equation. So as we can see, per mole of H2SO4, we need 2 moles of NaOH. So that means that our number of moles of NaOH is twice our number of moles of H2SO4. And I should put H2SO4 here just to remember. So that means it's 2 times this value here, which is 10.0 times 10 to the minus 3 moles. Again, keeping the 3 significant digits. So our mass is our molar mass times our number of moles. So then our mass of NaOH, the question gives our molar mass as 40.0 grams per mole times 10.0. And so we're going to get 0.400 grams. Again, keeping things to 3 significant digits. And so then there's our mass of sodium hydroxide. So just relating it to the balance, so we get 0.01 moles, which is 10 times 10 to the minus 3. And so then putting this all through, we get 0.4 grams of NaOH, which I'm just using 0.400 because everything's given to, well, the the only things that you need to worry about are the measured values for sulfuric acid, and the smallest significant digits there is 3, so 0.400. I'd say the solution is correct. 0.400 with sig figs. So that's good.